Exam question revision video for GCSE June 2018, the higher paper, Unit 2, question 10. Okay, here's the question. We are asked to factorise this expression, and we can see we've got the highest power of any of the algebraic terms in there is a squared, so we've got some kind of quadratic expression, and we're asked to factorise it. It's only worth 2 marks. So it shouldn't be too demanding, but we do need to think about this quite carefully. So there's a couple of things we need to be aware of. So thinking, is there anything that stands out about this expression? Is there anything that looks common to both parts? I can't see anything common to both 4m squared and 289. Is there anything that stands out about these numbers? Right, let's go and explore. Okay, let's have a look at expanding these pairs of double brackets just to see what happens. So in here I've got x plus 5 squared, if you like, because this times by itself. And if I expand that, I get x squared, 5x at 5x, and the 25 on the end. So I get 3 terms, the x squared term, the x term, if you like, so I've got my quadratic term, my linear term, and my constant bit on the end. If I do the same, but with this minus 5 swapped in with a positive 5, still get the 4 terms initially, but the minus 5 and the plus 5 cancel each other off. So I just end up with a quadratic term, the x squared, and the minus 25 in the end. We have a look at one more example. So if I do x plus 7 times x plus 7, again we get the same thing, quadratic term, linear term, and a constant on the end. And again, with x minus 7, x plus 7, those linear terms in the middle cancel out. Now if we just flip through and have a look at the rest, we can see this pattern keeps going, and even if I have a coefficient of this x at the front, a number of x's at the front of the brackets, I still have this same phenomenon happening where I have a linear term or in the middle of this expression, but it disappears in these ones, and that's a really powerful thing. So the ones on the left are called perfect squares. And you might like to think about these. You can recognise these because 10 is related to the 5 and the 5, and the 25 is also related to the 5 and the 5, and you can think about why. And that kind of logic will follow all the way down. And the ones on the right are called the difference of 2 squares, because you can see at the end the result of expanding these brackets. I've got a square thing, x squared, take away 25, which is also a square thing. So a difference meaning subtract. I've always got the difference of the square thing, so x squared and 49, which is 7 squared. So this is what we're going to look at, and we're trying to spot these square numbers, what we're doing. So let's have a look at the actual question from this paper then. 4m squared and taking away 289. And the first thing we go is, oh, 289. Oh, there's nothing common in both of these, so it is 289 a square number. Because I think 4m squared, they're definitely both square terms in there. So 289, I can figure out is 17 squared, and 4m squared I know is the same as 2m if I put it in brackets all squared. So what that means is 4m squared minus 289, I can write as 2m minus 17 times 2m plus 17. So you're just looking for these square numbers and the difference between them. They have to be a subtraction for you to do this really nice factorising. So we're going to do a little bit on some Pythagoras in a second, but just before we do that, we're going to look at some square numbers in a bit more detail. And so you know your square numbers, 4 squared 16, 5 squared 25, etc. Don't forget a square number is called a square number, because if you do 8 squared, 8 by 8, and for you to draw that, as I have done here, you get a square. And that's why they're called square numbers. If I was to kind of overlay 2 of them together, so 2 squared and 1 squared, I can see that if I was to work out 2 squared and subtract 1 squared, I'd be left with just these 3 red dots, 3 being an odd number. And if I did 3 squared, take away 2 squared, so take away all of this top, I'd just be left with these 5 blue crosses, again 5 being an odd number. And if I did 4 squared, take away 3 squared, I'm just left with this L shape again, and I quickly count out that L shape is 7. So again, I'm always getting an odd number. And if you think about what's going on in this L shape, you've got a pair, another pair, another pair, and then an odd one in the corner on its own. So I've got lots of pairs, and one on its own gives me an odd number. And this goes all the way through. Just to highlight that even more so, if I look at 6 squared and I wanted to take away 5 squared, just so we can see it really clearly, it would look something like this. And I'm left with 11 dots. So if I did 6 squared, take away 5 squared, 36 take away 25, I'm left with 11 dots. 6 and 5, when I square them and I subtract them, I'm left with 11 dots. It's crazy. 6 and 5, I end up with 11 dots. So what we can spot is that the difference between any two of these consecutive numbers, any of these L shapes, has an odd number of dots or crosses in it. So when we do the difference between any two consecutive squares, we get an odd number. That's something we're going to need in a sec. Okay, so we're going to have a quick look at some Pythagorean triples now. We know about the consecutive squares and when we take them away, what we get. If we look at Pythagorean triple, we're talking about a right angled triangle that has all three sides are integers. So 3, 4, 5 works, 5, 12, 13 works. And when I say works, it means if we put 3 and 4 into for A and B, we get 5 squared, or 25. Put 5 and 12 in, I get 13 squared. So they're very nice because they're integers and they are quite unusual, but there's an infinite number of them. So you can always come up with more. Normally on the non-calculator paper, if they're giving you a Pythagoras question, or on the calculator paper if they're not a Pythagorean triple. So let's explore this, because if I rearrange Pythagoras' formula up here, I have c squared minus b squared, and I'm going, difference of 2 squares, which I know I can factorise to be c plus b times c minus b. Now, I want to start out with a value for a and figure out what c and b are. I want to make up this triangle. So if I start with a value for a, is there anything I can do to help myself out? Now remember on the last slide we talked about the difference of two square numbers, if they're consecutive, gives us an odd. So if I decide I'm going to work with a squared being an odd, I'll go from there. Now we know an odd number squared is equal to an odd. So if, for example, I started with 3 squared, that would be good because that's the same as 9. So either 3 squared equals c squared minus b squared, or I can think of that as 9. So this is good because I definitely know that 9, being an odd number, is the difference of 2, and this is the important bit, consecutive squares. But what are they? So c and b must be adjacent to each other on the number line in terms of integers, 1 apart. What could they be and how do I figure it out? So remember what we mean by them being adjacent. 5 and 6, when we subtracted them, we got an odd number of dots. So 5 and 6, we squared them and subtracted them, we got 11. I'm just going to say that again. 5 squared and 6 squared, when I subtracted them from each other, I got 11. 5 and 6 led me to 11. You might spot something there. So in our case, we've got 9. So how do we figure out what these two numbers are? So we could take a bit of a stab in the dark, but let's think about this and what we know. So we know that 9 must be equal to c plus b times c minus b, and we know that c and b are consecutive. So if they're consecutive, they're next to each other. So if I subtract one from the other, so c minus b, I would get 1. So if this bracket is equal to 1, this bracket must be equal to 9, because I know they multiply to make 9. So I know that the first bracket must be equal to 9, their second bracket must be equal to 1. So I'm going to do a little subtraction. C minus b equals 1, just writing that out, and c plus b must equal 9. So I know these two little things, and I could do some simultaneous equations to solve them, but you might just be able to figure out in the top of your head what c and b must be. So if I pop c and b into the brackets, into this factorised version, I get 5 plus 4, 5 minus 4, which is 9 times 1, which is what I wanted, or 5 squared, take away 4 squared. So I've generated another triple, or I've generated the triple we had before. And I can rearrange that to be 3 squared plus 4 squared equals 5 squared. And there you can see it. 5 squared take away 4 squared gives me 9 crosses. And I've got the little triangle there that shows it 3, 4, 5. So let's very quickly try and find one more. So the same starting point, I take Pythagoras' theorem, I rearrange it to see my difference of two squares. I remind myself that I'm only using odd numbers because odds can be found as the difference of two consecutive squares. So I want a triangle that has one side length of 15 and it follows Pythagoras as a right angle triangle. What would the other two sides be? So 15 squared I know is 225. Because I know 225 is odd and now I must be able to write it as two consecutive squares. So I think of it in this factorised form. And because they're consecutive, c take away b must be equal to 1. And c plus b must be equal to 225. So I have these two little equations and you might be able to just figure them out without too much working out. And you come out with c being 113 and b being 112. So if I tidy that up and express it as the difference of two squares, I've got 15 squared equals 113 squared minus 112 squared. Two consecutive square numbers, and when I rearrange it, I've got 15 squared plus 112 squared equals 113 squared. Let's have a look at a picture of that. There's lots of different ways you could draw that, but I've drawn a circle with a radius 113, a base of 15, and a height of 112. I wonder how many different ways you could draw that triangle in that circle, but all right angle triangles within a circle. And that is the end of this little video. So I hope that's helped. Video on the difference of two squares and solving quadratics with that method are Unit 2, question 12. So do take a look at that next. It will join it all together. Good luck!